Great day, students, and welcome to day 3 of Labmas. And I need to be honest with you, I don't know what we're going to do today. We've already done some great experiments this week. I'm just not sure. So I'm lacking motivation. What can we... Whoa. What's happening? Oh my goodness. This is a Labmas miracle, ladies and gentlemen. Oh my goodness, this is a dream come true. Wait. Oh, here we go. This is Mr. Sergeant's dream come true. I got my lightsaber. I am ready. But the question I have is, how did we get here? How did I get here? How are we flying right now? How are we moving in space right now? So many questions, so little time. But ladies and gentlemen, today's Labmas experiment is going to deal with both rockets, spaceships, and how things move in space. Now we are back into reality. But ladies and gentlemen, the force is still strong with Mr. Sergeant, and the force is still strong with each and every one of you. Wait a minute, force. That could be what our lesson's going to be about today. Ladies and gentlemen, for day 3 of Labmas, we are going to deal with what we call propulsion. We're going to be talking about the 4 forces that act on something that's flying. And we're going to be talking about how spaceships, how rockets shoot in the air. And we're going to be doing a lab that shows how things move. Now, before we do any of that, we need to know our research. We need to know our background information. And ladies and gentlemen, it's pretty fun. And later on in the year, we're going to be talking even more about this word, aerodynamics. Now, aerodynamics is the ability of things to fly. It's the ability to fight through forces, to fight through, well, what's the force that keeps us on Earth? You're right, it's gravity, and we know one of our mottos in Mr. Sergeant's class is gravity always wins. And ladies and gentlemen, for a rocket, for a spaceship, for anything to fly, it needs to find a way to defeat the force of gravity. So what we're going to do for our background information is let's talk about those 4 forces that a plane needs or a rocket needs in order to defeat gravity. So the 4 forces we're going to be talking about: gravity, thrust, lift, and drag. And just like in the ecosystems, each one of them needs to have a balance. So let's talk about these 4 forces right now, and then we're going to test a few. First, let's talk about gravity. Gravity is that force that pulls us down to Earth. The Earth is spinning, has rotation, and it has mass. Therefore, if it has rotation and has mass, it has gravity. And for the most part, I am very thankful that we have gravity because it keeps us on Earth. Now, in order for something to fly, like a rocket or a spaceship or even an airplane, there needs to be a counterforce, which means a force that goes against gravity. Well, we have lift. Well, how do we get things off the ground? We lift them, don't we? And in order for a plane to even get in the air, it has to have enough lift to fight gravity. All right. Now, if you think about a plane needs to have lift for a longer period of time because sometimes planes are in the air for a very long time. And if you think about a rocket shooting off into space, the lift must be incredible because there's so much force that's needed to lift that rocket into space that it beats gravity. Pilots, astronauts, People who are in space need to have the understanding of these forces in order to fly. Sometimes you're going to need more thrust than you're going to need drag. Sometimes you're going to need more lift than you are going to need gravity and pulling down. Ladies and gentlemen, flying's not easy. Rockets aren't easy. Airplanes aren't easy. But our experiment today is going to be very easy. For our experiment today, we are going to see propulsion, which means being propelled forward. We're going to see how thrust happens, but we're also going to observe the effects of gravity. So ladies and gentlemen, let's head on over to the lab. We are back in the lab, ladies and gentlemen, and today, once again, we're going to be learning about aerodynamics, propulsion, the four forces, but I'm in the wrong gear to fly, aren't I? Well, let's fix that. No, wait a minute. This isn't the right gear either. Hold on. Much better, ladies and gentlemen. Though that costume felt right, not right now. We're maybe talking about forces, but, well, we need to learn about the science first. And what better way to learn about the science than in our lab coats? Now, the goal for day 3 today is, well, our question. Can we model the forces needed for a plane or a rocket to fly? Well, to do this, we have a few supplies that we're going to be needing and we're going to be using for this. And the materials that we're going to be using are pretty simple. First, one of my favorite science tools all time, and that is balloons. And you can choose any color, it doesn't matter. Some people say that blue flies a little bit faster, but there's no science behind that. The next thing you're going to need, a bendy straw. All right. Now these flexi straws are getting harder to find, but anything you can use that looks like a straw. I've seen people using pens where they take out the pen part and take off the top, and they just have a tube. Because pretty much we just need a tube. You can't have a science experiment without trusty duct tape. Now we got duct tape, we got regular tape. We're going to try both. And for something different this year, we're going to be using popsicle sticks as well, as sort of like a base. And one more thing that you're going to need, I have some string or some yarn. Either one can be used because we sort of need a way to guide our rocket a little bit, and the string and the yarn will definitely help. So my hypothesis is, yes, using these materials, we can definitely show and model the way planes and rockets move. So let's see how to build it. So the first thing that I am going to do is I am going to attach my popsicle stick to the straw. Now the popsicle stick is going to act as our base, and all we need to do is get a little bit of tape, like that. And I'm going to half it just so I can use more tape here. And we are going to attach the popsicle stick to the straw. Now you want to get it as straight as possible, and you'll see why when we test it. And you don't want to squeeze it too tight because we don't want the straw to bend at all. We want the straw as straight as possible. All right, so you find the center of the popsicle stick and you just go ahead and tape it. Just like that. Okay, so it should end up looking like that. All right, now the next thing we need to do is we need to blow up our balloon. Now I chose pink today because, well, it kind of matches my shirt and my tie. So what we're gonna do is we have to stretch out the balloon first. So let's go ahead and blow up the balloon. There you go. So now it is stretched, so we can see how we can put this on. Now, we want our balloon to move forward. Now, we know because of Newton's laws of motion, for every action that's an opposite but equal reaction, if I let this go, it's gonna go that way because the air is gonna be pushed out here and propel the balloon forward. So when we attach our popsicle stick and straw, we wanna make sure that it is going in the same direction as the end of our balloon. The next thing that we do is we take our string or our yarn, depending, and you get a bit of it. I'm gonna get a little bit longer here, and you cut it or break it, and you tie it to something. Like I have my chair right here, so I'm gonna go ahead and tie it to my chair. All right, and you wanna find something that's equal height. I have an easel here that I'm gonna use that gives it about the same height. All right, now you don't tie it off yet because, well, we gotta do something kind of important, and that is put the string through the straw. So let's go ahead and do that. And there we go. So now it is attached. And I'm gonna go ahead and I'm gonna tie off this other end. In fact, I'm gonna make it a little wider so we can see it a little bit better. All right, right now this is just floating in air. So the next thing I need to do, I need to blow my balloon back up. All right, so now the balloon's back up, it is sticking. And what that's gonna do is we added force to the balloon, and when we let it go, it should have enough thrust. You guys remember what thrust is? Thrust is that force that makes things move forward to move forward. So let's go ahead and test it. Look at that. It moved right along the line, and I think if I made the line longer, it would have kept going. Now, if you notice, the balloon rocket had enough propulsion to propel forward, or enough thrust to move forward. And eventually it had some drag to stop it, and eventually it ran out of fuel, which was our air, but it still moved forward. Now, the questions I have for you, what would you change about it? I know we could change the color, we could change the decorations of it, and that may make it fly better, but what would you change? Would we make the string longer to see the max effort and max thrust that the rocket took off at? It's a good question. So I encourage all of you to try this at home. We're gonna be doing it in class, but I want you to try it at home and most of all, have fun with it, ladies and gentlemen. This is one of those experiments you can do with your family. You do with your little brothers and sisters. It's a fun rainy day or snowy day activity that you can just enjoy science, and that is the spirit of Labmas. So ladies and gentlemen, thank you for joining me today. And once again, I say it every day, I cannot wait to see each and every one of you tomorrow.